So who can give me two numbers that multiply to get 8? 4 and 2, right? Now is 2 a prime number? Yes. Is 4 a prime number? No. 2 times 2, right? All right, so then let's go ahead and circle our prime numbers. Very good. All right, now 10. What two numbers multiply to get 10? 2 and 5. Are those both prime numbers? Perfect. So I'm going to go ahead and circle those. All right, down here I'm going to write 8 is 2 times 2 times 2. And 10, oh, and we have a C. And 10 is 2 times 5. Now, what numbers do both of these have in common? They have 1, 2 in common, right? Is there another 2 and 10? Or another 5 and 8? And do they both have a C? No. All right, so the only thing that we are going to put up here for our greatest common factor, because they only have 1, 2 in common, we're going to write that our greatest common factor is what? 2. Very good. Remember, if they both don't have a variable, then they don't have that in common. All right, now let's look at the second one. We have 32a squared b to the third minus... So, since they both don't have a c, then they don't have that in common. All right, what two numbers multiply to get 32? 4 and 8. All right, are those prime, Jemiah? No. What two numbers can multiply to get 4? 2 and 2. What about 8? 2 and 4. And then that 4, 2 and 2, right? All right, I'm going to circle my prime numbers. Moving over to 28. What two numbers can we multiply to get 28? 7 times what? 4? Perfect. 7 is prime. 2 times 2. Thank you. Good job. All right, now 24. Anybody. Actually, let's do Haley. What two numbers multiply to get 24, Haley? 12 and 2. Circle the 2.
And then 12 equals 6 times 2.
6 times 2.
And then circle the 2. 6 goes into 3 times 2, and you just circle this 2.
Very good. All right, now I'm going to go ahead and write these out. I have 32 is equal to 2 times 2 times 2 times 2 times 2. I have 28.
Negative. I thought negative.
Yes. Very good. Good catch. That's awesome. All right, so I have 2 times 2 times 7. And then for 24, I have 2 times 2 times 2 times 3. Okay, now let's look at the numbers that we all have in common. What numbers do you see that all three have in common? 2?
Not all 3, but yeah.
Yeah, all three of them have a 2 in common. What else?
2.
They have another 2 in common, right? Do you see anything else that they all have the same? No. This one has, 32 has a 2 and 24 has a 2, but negative 28 doesn't have another 2, right? So we can't circle that. So, because I have two 2's, I'm going to take 2 times 2 to get my greatest common factor.
4.
Very good. So, 2 times 2 equals 4. And then don't forget your variables up here either. So I have a squared, a, and a to the third. What is the smallest number of a's that I have?
Just A by itself.
Just a by itself, right? You can think of a by itself as a to the first, but then when we write it, we just put an a. All right, now let's look at our b's. We have b to the third, b to the fifth, and we have no b. So what is the smallest number of b's that each of these have? Not b to the third,
0.
because this one does not have a b, right? So they don't all have a b in common. So we don't have to put a b for our answer. So our greatest common factor is going to be 4a. Okay, does everybody have that written down? Perfect. How you doing over here, Deontay? All right, let's look at number 3 on the back. Two numbers that multiply together to get 54 are, Brendan? 6 and 9. All right, two numbers that multiply to get 6.
2 and 3.
And are those prime? Yes. Good. And 9? 3 and 3. Encircle those. Thank you very much. All right. Two numbers that multiply together to get 45. Darius? 5 and 9. 5 is prime. Go ahead and circle that. Two numbers that multiply to get 9. 3 and 3. Very good. All right. Two numbers that multiply to get 50. Nick? 5 and 10. Two numbers that multiply to get 10. 2 and 5. Thank you. All right, let's bring those numbers down. So I have 54 equals 2 times 3 times 3 times 3. 45, I have 3 times 3 times 5. And 50. This girl. Good thing you are here, Jemiah, because you are catching me. I have 2 times 5 times 5. Okay. What numbers do we see that are the same, Rihanna?
3 and 5.
3 and 5.
No, it's not. No, because
It's an error.
on 45,
3 of them.
there's no 2. So basically,
You know it. You know this. Do they all have a number in common? All.
they don't. So don't you just count the 3 and the 5?
Mm-mm.
Or am I wrong?
Nope. Nope. But I like how you were catching yourself. That's awesome. So if they don't all have a number in common, remember, not 0, each of these numbers can be multiplied by 1. So basically our greatest common factor is going to be 1 if we don't have that in common. But we don't have to write 1. So let's look at our variables.
But we do have to write.
You don't necessarily have to write 1. You can if you want to. So if we take all these times 1, we can have a greatest common factor of 1. And then go ahead and look at your variables. So I have e squared, e to the third, and e squared. What is the smallest number of e's that I have? E to the second. Very good. E to the second. And then let's look at the f's. I have f to the third, f, and f squared. What is the smallest number of f's?
Squared. Just F by itself.
Just f by itself, right? Very good.
Okay, so you don't add them together, like if you got how many each, like you don't add them together, you just put the lowest one.
Yes.
Okay.
Yep. Nope, don't add.
Doing that at the beginning.
Do not add exponents together. Okay, you're just looking for the smallest number. And we'll do that later on, I believe, right, Miss Lidekin? We'll add the exponents together, or does that ever happen? Not in this lesson necessarily, but like.
Oh yeah, not in this lesson. We're just talking about what they have in common. You guys have added exponents together already. Yeah, we won't for the remainder of the year. Well, you'll add them, but you'll add them in a manner that helps you to find the total area. It doesn't make sense how I'm explaining it now, but when we get into like the lesson Friday, you'll kind of understand what I mean by what I'm saying right now. So you're not going to necessarily add the exponents together how you see them, like right there, but when you're using the greatest common factor, so Friday's lesson is factoring using GCFF. When you do that, then you'll have to kind of add the exponents together. But like I said, it's not like what we've done in the past. It's going to be a little bit different. We'll get into that more on Friday, though.
Remember we took a quiz on Monday? So, but for right now, make sure that you guys are just finding that smallest exponent. That's what we're looking for. All right, so when you have everything copied down, go ahead and pass those openers up to me.